All right. It's 8 o'clock Eastern, 5 Pacific. So we're going to start the live. I'm Dave Young, co-founder of BlueStamp Engineering. I'm an electrical engineer. I've been designing circuits for 15 years. I also run a small consulting firm helping startups and small companies build electronics and release them to market. So we thought it'd be a good idea to get a bunch of people together to talk about my career, the things that I've done, and give you an opportunity to ask any questions you might have about what an electrical engineer does, what an entrepreneur does, how do you leave the corporate life in order to become an entrepreneur. Really, any question you might have, please use the chat window. Brianna, our California director, is on, and she's going to be moderating those questions. So, yeah, let's keep the lines of communication open, and please chime in with anything you may be wondering. So to get started, I've kind of always known that I like to build things from when I was 5 or 6 years old, just sitting there with Legos. So getting into engineering was, I don't want to see like a foregone conclusion, but I knew that I wanted to make stuff or build things from a young age, and really where I got to dial it in was in high school. So I know a lot of you students out there, I know particularly from teaching BlueStamp for so many years, that the high school years, you really have limited options in terms of what you can build that's meaningful. There's projects you can take on at home by yourself, and some schools have some opportunities, and there's FIRST Robotics, which are actually a lot better than the opportunities that I had when I was going to high school. But the idea that I had was take every tech class that my high school offered. I was fortunate. I went to a large public high school that had a lot of opportunities. So I was able to try a bunch of things. I was able to play with lasers, or use a wind tunnel, or build some simple robots. But every time I did one of those things, I found that it was like, wow, this is amazing. I want to keep building this kind of project, and I want to keep working on these kinds of classes. So that drove me to do more and more things. And really, what brought me to realize that there are more things beyond what school has to offer is X10 home automation. It's an old communication standard for turning lights on or turning fans on or doing all different things. And I had, by the time I was done with the projects I was building in high school, I had my computer hooked up to my lights, running all kinds of different programs. So if a motion detector went off, it would do X, Y, Z, or if it was too bright in the room, it would close my blinds. There was all kinds of things that I had put together just as a hobby. And X10 was a tool that, similar to something like Arduino and Raspberry Pi is today, where it's a tool that kind of takes the edge off of a lot of the very technical and difficult things that you have to get through in order to get started. So if you're out there, if you're a high school student and you're wondering what it is you can do, especially during this crazy COVID time, you're sitting at home with not a lot to do, I would highly suggest you just start with anything. If something seems like it's something you enjoy doing, jump right in, give it a shot, and see if it's fun. BlueStamp, of course, is a summer program for high school students where they get to build a project that they feel passionate about or they feel interested in. And while that's helpful to have all the tools and all the staff and everybody in a room together working to build projects, it's not necessary, and it's not the only way to do things. You can order projects, and you can start learning today by just building something or coming up with an idea and giving it a shot. On top of that, we have the wonderful world of the internet to make all of this isolation seem a little bit more reasonable. So if you had questions, there's a lot of forums out there. There's a lot of people willing to help. There are many different ways that high school students, or somebody that is looking for something to do while they're cooped up in their house, you can come up with something and really make something interesting and try out something that you might otherwise not have an opportunity to do or not have the time to do. So anyways, when I'm in high school, I was going through all of my different projects and trying to get good grades and trying to get good test scores in order to get into college. I did okay at that. I wouldn't say I was like this phenomenal student that was getting straight A's or even all A's and B's. I got some C's, and I struggled through a lot of classes. but I still worked at it, and I still did a lot of side projects. So when it came time to apply to college, I had some pretty compelling stories that I could tell about the projects I had built, or the competitions I had entered, or really what my interests were. So a college might say like, yeah, he's got decent grades, he got decent test scores, but he definitely seems into the projects he's building. He definitely seems like he's interested in engineering, and it's something he wants to do. I always tell our BlueStamp students, like, we talk all the time, how do you get into college? How do you present yourself in the best light? And the stories that you can tell can drive so much about your admissions, that you want to make sure that you're explaining what it is that you want to do at that college well. So if you want to go there to learn how to build projects, you want to go there to learn how to make amazing things, and talk about that. Say, I've done these things before, and it was amazing, and I understand this is a school that will allow me to do even more. So please let me in so that I can do some cool stuff and show you what I'm made of. And I was lucky enough to get into Case Western Reserve. It's in Cleveland, Ohio. It's an excellent engineering school. And as soon as I got into college, I was like, okay, great. I'm an electrical engineer. I know it because I like to build little electronic things. The home automation thing was wonderful. Funny enough, I knew that I didn't want to write any code. I decided that I wouldn't take any software classes or programming classes beyond the one required programming class. And my advisor who taught the one programming class that I took, he kept telling me, you really ought to be taking more programming classes. I said, yeah, but I don't want to give any employers the idea that I'd be wanting to write code for a living. That's not what I want to do all day, every day. I'd like to work with my hands. I like to solder, build circuits, use oscilloscope probes. I like to use real world devices. And so he said, all right, it's your choice. So instead, since I wasn't writing a bunch of code, I had all of this extra time that I could take every laboratory-based class that my school, the electrical engineering school, offered. So I took antennas and magnetic theory design, and I did every actual lab class where I got to build something. And that made first college so much more fun, because I'm sitting there doing labs, which take way more time, but is way better than sitting there reading or sitting there trying to memorize anything. And the second thing it did for me is when I went to apply to co-ops. So co-ops is like a long internship. You take a semester off school, and you will spend 8 months working for a company instead of just like 2 or 3 months, which in an engineering field, like a 2 or 3 month internship is not nearly as valuable as an 8-month internship. So when I went to apply to co-op, I had a lot more interesting things to talk about to the potential employers when they were looking for people to hire. So instead of talking to somebody who clearly just wanted to either make a paycheck or get something on their resume, they were talking to somebody who actively wanted to make things, build things, and contribute to a company that's trying to make money or make products or make something happen. So I was really fortunate that I got a co-op with a local company building audio equipment. And I love to talk about the first day at co-op. Joe Burley, who was my boss, wonderful guy, took me into a sound room. So it's basically a padded room that's very dark. And he walked me over to a mic stand. He said, okay, you're going to put this microphone in here and walk over to the computer, get out of the way, and press this button. And then the sound went boop. It did what's called an audio sweep of the microphone so that you could see what the audio profile was of the microphone. And then on the computer, it would show up with the graph of what the frequency response was of the microphone. And so he explained it to me. This is the frequency response. If it's outside of these bands, it's a fail. If it's inside of these bands, it's a pass. I said, great, that sounds neat. He said, okay, there's 200 microphones. Have at it. I'll be back at lunch. So he left me in the room to sit there and test microphones for hours. And I was like, oh, this is bad. I don't know if I'm going to like this very much. Anyways, it turns out it's something that many companies like to do to make sure a student will actually work and do what they're told. Is they'll put them in front of something that might not be so pleasant, and they'll have them frequency sweep microphones. So anyways, I got through that, and eventually I got to do cool projects like take real data, design my own tests, build systems that would test prototypes, maybe even modify some prototypes. So that co-op was a spectacular opportunity for me. In 8 months, I can't believe how much I learned in 8 months. And so if anybody has an opportunity to go around and get a co-op, or their school has a co-op program, I would highly, highly suggest taking that opportunity once they're in college, because real world experience is hard to come by, and it's really truly valuable if you're doing something more than just like, getting people coffee or doing menial tasks like spreadsheet work. So anyways, that's college. I went to college, finished up, did better than I did in high school. It was a lot harder, but I worked harder because it was more interesting, and I had a lot more fun, and it's a little bit more focused. And then after college, I had a choice. I could either get my master's degree. I was in a 5-year accelerated master's program where you can do 4 years and then stick around for an extra year and get your master's. But I ran out of money at the end of those first 4 years. So between like the scholarships running out after 4 years and the money being gone, I decided to work full time during the day, pay for my school that way, and then at night I would go back and take classes. And that turned out to be a really good deal because employers will pay for some of your schooling if you go at night. So I got the opportunity to take classes at night and have a master's degree after. It took forever. It took like 3 or 4 years, but and have the employer pay for a lot of it, which was, again, a really amazing opportunity. So I walked out after, I guess it'd be 7 years, because it was 4 years of undergraduate and then 3 years of working full time and taking master's courses at night. And I was able to get my master's degree and walk out with all the education I think I'll need for my whole life. Hopefully, don't need to go back to school. So then, how did I get that first job that was able to allow me to do my master's degree at night? And that actually happened to be my co-op. So when I was on co-op, they liked my work, and so they said, "Hey, great job. We'd like to hire you part-time." So while I was going to school as an undergraduate student, I did some part-time work. And then after I was able to get my undergraduate degree, they said, "Hey, you've got your undergraduate degree. Why don't we hire you as an electrical engineer? And you can go to school at night, and you can do whatever you want." And that was another really wonderful opportunity. And it was a strong bit of affirmation to know that my colleagues thought that highly of me, that, "Hey, we like your work so much, we want you to keep coming back, and we want you to keep working with us." And I'm still humbled by that today, because not everybody gets that opportunity, especially not all co-op students and internship students always work as hard as they maybe could, or they're used to a more academic, slower pace lifestyle that isn't always compatible with working for a small company where they have to really hustle and they really have to work hard. So having that little bit of affirmation was pretty wonderful. So anyways, I continued to work there. But sadly, that company was sold to another company that moved it to someplace in Indiana. So that job wasn't going to be like the forever job. So I got another job in Cleveland, in the same city, before I even finished my master's degree. That was at Keithley. They make analog electronics, actually some measurement equipment. So they do voltmeters, current meters, electrical engineering tools. And I had so much to learn to take on that job. It was frightening. Like, the amount of technical depth that I needed to do my job, even as an entry-level employee, was staggering relative to anything I'd seen before. And the company was spectacular at teaching people coming in from their college career or whatever, and getting them up to speed with this very challenging analog electronics world. And I so appreciate all the time that I gained learning the techniques that I learned, because now I can apply it to my daily career. And then facing that steep learning curve certainly made me a stronger engineer and made me able to take on much more challenging things, not just in engineering, but like working in the measurement industry. Everything's about counting things up and making sure things are accurate. And you can apply that to business. You can apply that to finance. You can apply that to your home life. You can apply that to really anything that you need to decide, like, is this a good thing or is this a bad thing? Is this good enough? Is it not good enough? That rigor and that methodology has carried with me my entire career, so that I can quickly assess if something's good or something's not good, or we don't have enough information. So I worked at Keithley and really had a great time. I worked there through 2008. Right now we're in the middle of, like, economic craziness and uncertainty, which feels very similar to 2008, when nobody knew what money meant anymore. Like, everybody thought they knew what money meant in 2007, and then in 2008, when companies were folding, it was like, wait, maybe we don't really understand money at all. To the point where some people were questioning even the entire fiat currency system. Anyways, so that works its way down to people in companies like Keithley, where they cut entire divisions. And to be blunt, there were better engineers than myself getting laid off. And to me, that was striking. When I was sitting there watching them lay off people that were phenomenal engineers just because they were on the wrong project. And I guess it's not good to fire somebody like me so that the other guy can come and take my spot because he's a better engineer. That, while that can happen, I don't think that's typically done. But that was like a wake-up call. Like, okay, so you thought you were good at your job, but that doesn't always matter for the whole story. So at that point, I started saving up a bunch of money. It's like, I need to put some money in the bank because who knows what's going to happen. I could, tomorrow they could shut down my division and I'd be out without a job. And so I started saving cash. And then I got my master's degree. And so instead of going to school at night, I started moonlighting as an engineer, helping small companies and startups. Really, it was a friend of mine's company. He was like, hey, I'm doing this thing. Can we get your help on this circuit? So I was working, here and there, helping him with some circuits. And then eventually that startup had offered me a job. They're like, hey, why don't you come just work for us? It's fun to work here. It's a cool place to be. So why don't you come work for us? And I was like, well, yeah, that sounds good. I'd like something new. I was 25, 26. So I was ready for something new. I had a little bit more adventure that I wanted to try. I was like, yeah, let's give it a shot. Here, who knows? This is 2010, so the financial crisis was at least a couple years in the rearview mirror, and I had a bunch of cash saved up, so I had the ability to make things or try things new that didn't really happen. So, anyways, that company ran out of money like 6 months later. It didn't go very far. And I used my skills there to start my consulting firm and BlueStamp Engineering. So now I've been doing that for the last 10 years. Now I spend my days designing electronics and my nights trying to figure out how to help BlueStamp students get the next level of engineering education that they would be interested in. So that's me. That's my career path. A few stories from my career path. I want to open it up to questions. And answer any questions somebody may have. So I'm not sure if, let's see what we have for a list. Okay, so what's something that seems like magic, but is actually electrical engineering? Cell phones. Cell phones. Before 2007, there were no iPhones. And I don't know, my mom got her first cell phone in like 1995. So, and that was like amazing that you could carry around this thing like a walkie-talkie and literally talk to somebody anywhere in the world. And today, even still, so I'm not an RF engineer. Today, even still, the RF that happens is a whole nother world of black magic that I don't even know about. Like, I can plug an antenna in onto my circuit design, and I might even be able to copy somebody's existing antenna and put it into one of my designs. But how somebody could design an antenna is, to me, still seems like black magic. So I got to think everybody else, it would be like, what is going on here? How is a signal able to go through the air from A to B? But that is like, there are equations and there are methodologies and there are processes that are used, not always very well understood by everybody, actually usually not very well understood by everybody, but there are experts that could say like, oh, you want a cell phone? Sure, give me a month and I'll design you a cell phone antenna that can do Wi-Fi, Bluetooth, GPS, like it can do everything all in this little tiny area, and you can put it in a cell phone, and I'll sell it to you for $1 as long as you buy 10 million of them. So that'd be my answer. Antennas, huh? How do you even get those signals in and out? What's my favorite BlueStamp student success story? Wow, there's been a lot of success stories, and what's more, there's been a lot of different flavors of success stories. So at BlueStamp, just to give a little deeper of a primer, if not everybody knows about BlueStamp, you get 6 weeks, 4.5 hours a day, 5 days a week. So that's equivalent to like 2 semesters in high school. And you get to build whatever you're passionate about. And there's electrical engineer, computer science engineer, mechanical engineer. We have a bunch of engineers on staff to help you so that you can really reach for the stars, and you don't have to feel like you're all alone. You can feel like, I'm going to try something. It might not work, but as long as I try something, my instructors will be able to talk me through it and maybe give me a few more bits of advice. So at BlueStamp, we have many different types of students. We have students that have built like 10 robots, and we have students that did like 1 robot. And they can all work together. They can all work next to each other because each student has their own project and they're all working independently. So we get a big group working together and all working towards their own individual goals. It's not like everybody's doing the same thing. So there's no competition. There's no like, my project is further along than your project because we're making the same project. Like there's none of that. And so one student was in the I've not built anything before, and actually that student struggled academically. He had under a 2.0 GPA, but in the interview, it was like he has to come to this program. It's all he wants to do is build stuff. And actually, I saw a lot of myself, and he was like, he's like an academically worse version of myself. It's like, all I want to do is build stuff. Why am I bothering learning what Shakespeare is doing? All I want to do is build stuff. And so his grades reflected that. But at BlueStamp, we can accommodate students that have low GPAs because we don't really care. As long as you're passionate and you're interested and you won't give up, there's a spot for you at BlueStamp. And so he came in and he crushed his wind generator project, like absolutely crushed it. And he went so far as to wind each individual coil manually because he wanted to get the absolute best performance he possibly could. And it was truly amazing to see the outcome. And 6 months later, his mom called or emailed and said, hey, I just want you to know that student, I'm not using his name because I don't want to embarrass him. That student is way better at school and has doubled his GPA, and he's well on his way to succeeding. And it's because BlueStamp showed him there is a reason for all of these things you have to learn. It might not be immediately apparent, and it might just be you need a good grade so you can impress people who are impressed by that kind of thing. But that kind of turnaround was, it just made me feel good. It was an amazing success story. I've got another question. What would you recommend for someone at home who hasn't built anything but wants to start? Are there any simple starter projects that you know of? Oh, I love this question because with our COVID situation, I know, as I'm a parent now, and I know what it's like to have to homeschool children, even though my children are much younger in high school. And so as soon as it started happening, we decided to start putting together some programming that would help students build a project. So first, if you want to do it by yourself and you just want to start, I know SparkFun is still shipping, and I know Amazon is still shipping. Adafruit is not, but SparkFun.com and Amazon, they have many different projects. And find something that you would be interested in doing that has very good instructions. And go through it. Now, that's a little bit risky because it's very frustrating, and you don't know when you've never done any projects, you don't know what's a reasonable project or an unreasonable project given your skill level. And so that makes it tricky. You can rely on like the forum, or you can rely on the project description to kind of guide you if this is really easy or really not. But at BlueStamp, we want to really help. We really want to help the situation and give students a little bit more exposure, because I know there's a lot of downtime for many students, not all. Some students are getting like blasted with remote learning, but some students have a little bit more flexibility. So we want to offer a program where we'll guide you over Skype and video chat through a project. So if you're interested, say something in chat, or I guess email Brianna at bluestampengineering.com, and we can send you the information. But basically, that would be a more personal version of what I'm suggesting. So my suggestion is to just jump in and start something. And then if you're not sure what you want to do, you can look when we launch our remote learning program. First, you could just do the projects that we list and give it a shot. Or two, you could take the remote learning course that we're offering and actually have some help and make sure that you can get your way through. Okay. What can a student do to prepare themselves for an engineering career in high school? So same thing I did is if something smells like it's interesting to you, give it a shot. And if you don't like it, apply yourself a little bit. But if every time you do something, you're dreading it, then stop. I know I tried a lot of like mechanical projects. So like I built a remote control car, and that was heavily mechanical. And while I like doing it because it's fun to build things, when I got to a point that when it wasn't, there's assembly and then there's engineering. When I was assembling, I was happy. It was like, yes, this is easy and fun. And I get snap together, move. But when there was a situation that I didn't understand, I found it extremely frustrating. And for whatever reason, the mechanical side of things frustrating me happened, but the electrical side of things frustrating me didn't. I found the electrical stuff interesting and the mechanical stuff maddening, like pull my hair out maddening. So I realized through that experience, like, okay, I built the project. I hate this mechanical stuff. Well, it's fun as long as it's easy, but as soon as it's hard, I don't like it. Whereas the electrical engineering stuff, while it's frustrating and annoying, I found myself continuing to try to solve the problem without getting discouraged or without wanting to give up. And the more things you try and experiment with and go through, just because you try something you don't like it, that's okay. If you try something you fail, that's okay. Try something else. Try something else. Try something else. Just continue going through everything and give it a shot. A plug for BlueStamp. Come to BlueStamp, learn how to do projects. Really, what we are is an immersion program that does exactly that. Is we show students how to try different things and explore different things, and then we also add the extra support and guidance to make it a more positive experience, and to make sure that you can finish and understand things more clearly than you would if you were alone. But that doesn't mean you can't do things alone. There's so many cool projects you can do by yourself. And then the follow-up was how did you choose between all the fields of engineering? Well, I just mentioned between mechanical and electrical. I knew I didn't want to do chemical engineering. Chemical engineers make a lot of money, like big money. But I didn't want anything to do with chemical engineering. I struggled so hard just to get through introduction to chemistry for engineers. I had to go to my professor's office hours every day. Doc Ock ran a problem of the day, and everybody who was like having a hard time, every day you go see Doc for 5 to 25 minutes, and you do the problem, and you go home. I did that every day, and I still struggled to get through that class, and it was the easy one. So no chemical engineering, and yeah, I guess I never. Chemical engineering is really just another name for material science. So and I didn't like writing code because it's too much of the computer. So again, all these things I tried. I liked it. I didn't like it. I liked it. I didn't like it. And you can figure things out, and you just kind of refine your path from there. And you never know until you try it. So I'll look and get another question. Can you tell us more about the remote learning program? I don't think so, because we're just developing it now. The idea is you can pick one of 12 projects. You can either sign up by yourself and get paired with a small group of other students, like 3 to 5 students, and or you and your friends could just reserve an entire class just for you. For every class, we'll have a Slack channel, and we'll have a 1-hour video session or a 45-minute video session with the instructor every day for 5 days. And the goal will be you will be able to finish your project within those 5 days. And ideally, you would finish it earlier, and we will give you extra parts so that you can make modifications and adjust it. I don't know if I should really be talking about this because I haven't talked to the rest of my team. And who knows? It'll be a lot of fun. It'll be really interesting. You'll learn a lot. But beyond that, I don't think I can articulate anything more. Yeah, so I think those are all the questions that we have. Brianna, please chime in if there's something more that I should be answering. But yeah, I'm gonna sign off, and I hope you all are doing okay. You and all your people are safe, and you're able to stay happy. I know both of those things are not as easy to do as they were 3 months ago. So keep it up, and whatever you do, keep building and keep trying stuff. Thanks so much.